Pre-Calculus students. Today we got another exciting episode. Chapter 8-3, Algebraic Solutions of Trigonometric Equations. Now, you want to learn these skills to unlock the mysteries of the universe? I will show you how. This first example, we're going to start off easy and build up the complexity. 8 cos x minus 1 equals 0. I try to get x by itself, so I add 1, divide by 8. I end up with cos x equals 1 over 8. I'm going to go ahead and use inverse cosine on each side to get the x by itself. And look at me, I didn't give myself enough room to squeeze inverse cosine on that side, so let me just erase. Okay, so inverse cosine and cosine cancel, so x equals inverse cosine of 1 over 8. So I'm going to go ahead and just draw my little reference triangle here. So cosine is adjacent over hypotenuse, so 1 over 8, and cosine is positive in quadrant 1 and 4 because cosine is the x value and that's where x is positive. So I'm looking for that angle right there. Now we check and see, okay, is it one of our special triangles? Is it, a 30, 60, 90 or a 45, 45, 90? It's not, so we have to just use our calculator, type in inverse cosine of 1/8, and it's going to tell us it's 1.4455 radians. But remember, every 2 pi rotation gives us another answer, so we got to add 2 pi k, where k is an integer to represent 1, 2, 3, 4, 5 and so on rotations of 2 pi or 360 degrees. All right, and the other answer is going to be the negative version of it, because that would be the one in quadrant 4, so it's negative 1.445. Negative 1.4455 radians, and then you can add rotations of 2 pi to get the other answers. Okay, so that is the first one. Let's kick it up a notch. So now we have solved sine of 4x equals root 3 over 2. Now, the thing is, the inside, the 4x, I really want that to just be one letter. So I'm going to use a substitution to make it that way. I'll start off with u equal to 4x. And that's going to turn it into the simpler version of sine u equals root 3 over 2. All right, so I'm finding this angle u, so I will sketch my reference triangle. Now sine is positive in quadrant 1 and 2 because sine is the y coordinate, and that's the two coordinates where y is positive. And so since sine is opposite over hypotenuse, I label the triangle and I see that this is our 30, 60, 90 with the side opposite root 3 is the pi over 3 or the 60 degree angle. So I have my two answers there. One of them is going to be, I'll use the inverse sine on each side here. So I've got two answers. Either u is pi over 3 plus, don't forget our 2 pi k rotations. And the other one is, let's see, that would be pi minus pi over 3 for the one in the second quadrant. So that would be 2 pi over 3 plus 2 pi k rotation. Again, I got to put that 2 pi k so that it gives me all my possible solutions. Okay. Now, the thing is, I found angle u, but I want angle x. So I got to do a little back sub here. 4x equals pi over 3 plus 2 pi k, or 4x equals 2 pi over 3 plus 2 pi k. And now to solve for x, I'm going to simply divide by 4. I need to make sure I divide everything, including that 2 pi k rotation. So I'm going to get angle x is pi over 3 times 4, because the 4 goes in the denominator, plus 2 pi k over 4. Same thing on this answer. I'm going to divide by 4. X equals 2 pi over 3 times 4 divided 3 times 4 plus 2 pi k divided by 4. And after doing some simplification, I get pi over 12 plus, I can simplify this fraction here to pi over 2k. Or the other answer is x equals 2 pi over 12, which simplifies down to pi over 6 plus pi over 2k. And that is my final answer. One thing you probably notice is when you're solving trig equations, you always have two groups of answers. So make sure you get both. It's common just to get one answer and ignore the other half of the answers. So, all right. Awesome, we got that, box the answer, and we will move on to the next one. So this one's going to be, we're going to kick it up a notch again. So this one, find the solutions of 4 sine of x squared. Now that squared means, when we write it like that, it's means sine of x, and then the whole sine x part is squared. It's not like sine of parenthesis x squared. It's sine x, whole thing squared. Plus 5 sine x plus 1 equals 0. And in this, sometimes the question will ask you to just find the answers in a certain interval. So in this case, from negative pi to pi. So it's pretty much the same thing. It's just that we're going to just cut out any answer that's not in that interval. You'll see when I get to the end. All right, so first thing I'm going to say is I really want, I could sub out sine x for u, and it would be a quadratic. So let's do that. Let u equal sine x, and we get 4u squared plus 5u plus 1 equals 0. Remember, we did something like this when we were doing the exponential equations. So hopefully this strategy seems familiar. And it's a quadratic, and even better, it's a quadratic that I can factor quite easily to 4u plus 1 times u plus 1. So now I have two answers. U equals negative 1/4, and the other answer is u equal to negative 1. Okay, so I got u, but I need x. So I'm going to back substitute, put sine x in for the u to get my final answers. So I have sine x equals negative 1/4, or sine x equals negative 1. So I'm going to apply the inverse sine function to each side to get my angle x. So now I ask myself, okay, which angle gives me a sine of negative 1/4? So sine is negative. Remember, sine is the y coordinate. So sine is going to be negative in quadrant. Pause and think. Yep, it's the y coordinate. So it's negative in quadrants 3 and 4. So sine is opposite over hypotenuse. So I label my sides. And I'm looking for that angle x. Now, a quick analysis shows that this isn't one of my special triangles, so I got to put it into my calculator. And the calculator gives me the answer negative 0.2. Can't even read my own handwriting. 0.2527. But remember, I got to add 2 pi k to get all my possible answers. And the other answer comes from that angle x is 0.25 radians. So if I add pi to it, it's going to be, let's see, how did I write this answer? Did I add pi or did I? Yeah, I did. So the other one is going to be pi plus 0.25 radians. So it would be 3.3943 radians plus 2 pi k. Now, normally I would leave the answer like that, but the thing is they wanted the answers between negative pi and pi. So what I'm going to do here is I'm just going to plug in different values of k to get the answers in my interval. So if k is 0, negative 0.25, that's in between negative pi and pi. So I include that. And if I add 2 pi to that, then, or I'm sorry, if I add 2 pi to that, I'm going to be outside of my interval, right? Because I'm going to be more than pi. So that doesn't work. But if I subtract pi, subtract 2 pi, I'm also out of my interval. So now I go to my second set of answers, and 3.39 subtract 2 pi is an answer that would work, negative 2.8889. So that's another answer. Okay, then go to the other part where I say, where is sine equal to negative 1? Well, it's that angle right there, negative pi over 2. And I add 2 pi k rotation, but I only want the answers between negative pi and pi. And if I add 2 pi or subtract 2 pi from negative pi over 2, I'm outside my interval. So I just choose pi over 2. So basically we have 3 answers, 3 angles that will fit in our interval. Okay, so if they don't give you an interval, you just got to leave the plus 2 pi k. But if they give you an interval, you basically just have to plug in k's until you get the angles that are in the interval. And anytime you get outside the interval, then you don't need to include that angle. All right, one more example, or is it two more? No, I have two more. So solve cos times sine squared equals cos. Okay, let's get the x's on one side, subtract cos. Let's factor out a cos x, seems like a good idea. Cos x times sine squared x minus 1 equals 0. So by the zero product property, if two things multiply together to be 0, that means one of them has to be 0. So I get cos x equals 0 or sine squared x minus 1 equals 0. So if we look at that first part of the answer, cos x equals 0. Well, cos is 0. Let's see, cos is the x-coordinate, so it's going to be at pi over 2 and negative pi over 2. So, or 3 pi over 2, it doesn't matter. You could write it as 3 pi over 2 or negative pi over 2, I don't care. So my two sets of answers is pi over 2 plus 2 pi k, because again, every rotation of 2 pi gives me another answer, or 3 pi over 2 plus 2 pi k rotations. All right, let's get the other half of the answer. So sine squared x minus 1 equals 0. I add 1, sine squared x equals 1. Take the square root, so it's plus or minus 1 equals sine x. So let's see, when sine x is 1, it's going to be at pi over 2. And that's the only angle where sine is 1. So the answer is x equals pi over 2 plus any rotation of 2 pi. But I already got that answer from the other equation, cosine x equals 0, so I don't need to write it twice. So that answer is already good. And we also know where sine x is equal to negative 1. It's down there at 3 pi over 2. But we already got that set of answers as well. So there's no additional solutions that we get from the other part of the equation. So the final answer is just pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. All right. So one of the annoying things about trig is like there's a lot of little details you have to keep straight and not forget about, or and so it just takes a lot of practice problems to really master it. So if you're having trouble, I just recommend do more practice problems. I can give you more to do if you run out of the ones that I assign. Okay, last example, minus 6 sine squared x plus cos x plus 5 equals 0. Now I'm thinking I have sine and cos mixed, which is not great. So I'm going to use my identity that sine squared plus cosine squared equals 1, so sine squared equals 1 minus cos squared. I'm going to sub 1 minus cos squared in for the sine squared. The reason I'm doing that is I want to get just cos's. I don't want cos's and sines mixed together. So I multiply the negative 6 through, I combine the like terms, and I end up with a quadratic equation with cos x as my variable. So I get 6 cos squared x plus cos x minus 1 equals 0. I can factor this just as if it was like 6x squared plus x minus 1. So it's just the same idea. So I factor and I break it down into 2 cos x plus 1 times 3 cos x minus 1. And then that gets me that cos x is equal to negative 1/2. All right, cos is negative in quadrant 2 and 3. So I quickly sketch out my picture and I realize, oh, that's the special triangle where that angle is pi over 3. So one answer is pi over 3 plus, don't forget your 2 pi k rotations. The reality is, right, but that angle is not pi over 3, right? The reference angle is pi over 3. The actual angle is pi minus pi over 3, or pi over 2. Oh, no, it's easier to do it as pi minus pi over 3. So it's 2 pi over 3 plus 2 pi k. And the reference angle on the bottom triangle is also pi over 3, but that one is pi plus pi over 3 to get the actual angle. So it's 4 pi over 3 plus 2 pi k. The reality is if you forget your 2 pi k, it's like just going to be 1 point off, but try and get in a habit of including it in your answer. Okay, the other part, the other factor says cos x is equal to 1/3. That isn't one of our special triangles, so we got to use our calculator, inverse cosine of 1/3, and we get 1.23 radians is the reference angle in quadrant 1 plus 2 pi k rotations, or the negative version plus 2 pi k rotations. So I box it. Those are all my answers. And I am happy that I have finished the problem. And remember, k is an integer. Thank you very much. We'll see you in the next class. Bye.